Hey there, stargazers, and welcome to Astronomy Daily, your daily dose of what's happening out there in the cosmos. I'm Anna.
And I'm Avery. Today is Saturday, March 21st, 2026. And honestly, Anna, we've got another busy show today.
We really do. A moon rocket has arrived at the launch pad for the first time in over 50 years carrying astronauts. We've got a pair of weird dying stars behaving in ways nobody's ever seen before, and a comet that basically fell apart while Hubble happened to be watching, accidentally.
Plus, 15 brand new moons in our solar system, a growing garbage problem on our own moon, and the genuinely dramatic spacecraft story. One lost, one found.
It's a big one. Let's get into it.
We're going to start with NASA's Artemis II, and this one feels different. After months of delays, repairs, and anxious waiting, the rocket is finally on the pad.
At 11:21 a.m. Eastern Time on Friday, March 20th, NASA's Space Launch System rocket and Orion spacecraft arrived at Launchpad 39B at Kennedy Space Center in Florida after an 11-hour overnight journey from the Vehicle Assembly Building, hauled by the giant crawler transporter at less than 1 mile per hour.
A 322-foot tall moon rocket creeping through the night at jogging pace. And honestly, that's exactly how it should be.
It really is. And the current target launch date is no earlier than Wednesday, April 1st, which means we could be watching the first humans leave Earth's orbit in over 50 years in less than 2 weeks.
So who's on board? The Artemis II crew is Commander Reed Wiseman, pilot Victor Glover, and mission specialist Christina Koch, all from NASA, along with Canadian Space Agency mission specialist Jeremy Hansen.
And this mission is full of historic firsts. Victor Glover will become the first person of color to travel beyond Earth orbit. Christina Koch will be the first woman to do so, and Jeremy Hansen will be the first non-American citizen to leave Earth orbit.
They'll fly a free return trajectory around the moon and back to Earth in approximately 10 days. No landing, this is a test flight, but it's a crucial one.
Now, the road to the pad was not smooth. Earlier this year, a helium flow problem in the rocket's upper stage forced the team to roll the whole stack back to the Vehicle Assembly Building. That pushed the launch from February, then March, and now April.
But the team fixed what needed fixing, including replacing batteries on the flight termination system. And now, pad teams are moving into final countdown preparations.
The last time humans flew beyond Earth orbit was Apollo 17 in December 1972. That was over 53 years ago. April 1st cannot come soon enough.
We will absolutely be following this one. Let's move on.
All right, story 2 is pure stellar science, and it's one of those discoveries that makes you realize how much of the universe we still haven't seen yet.
Astronomers have found something that until now, nobody was sure could even exist. A pair of brown dwarf stars orbiting each other so closely that one is actively pulling material from the other.
Let's back up slightly. So what is a brown dwarf? So brown dwarfs are sometimes called failed stars. They're bigger than giant planets, but not massive enough to ignite and sustain hydrogen fusion the way our sun does. They sort of sit in a strange no man's land between planet and star.
And we know many of them exist in binary pairs, but this system, designated ZTF J1239 plus 8347, is something else entirely. These two brown dwarfs are in an incredibly tight orbit, completing a full loop around each other in 57 minutes.
57 minutes. For context, our moon takes about 27 days to orbit Earth. These two are practically on top of each other.
And because they're so close, the gravity of one is pulling material from the surface of the other, a process called mass transfer. This kind of behavior has been seen before in binary white dwarfs, the dense remnants of dead stars, but never in brown dwarfs. This is a first.
The research team led by Caltech graduate student Samuel Whitebook actually had colleagues who didn't believe the finding at first. One co-author said, and I love this, "We've told some of our colleagues about them, and they didn't believe such a thing exists."
Which is the best kind of science discovery. The system is only about 1,000 light years away, which is close enough that follow-up observations with the James Webb Telescope are being planned.
And what's the eventual fate of these two? Either they merge into a single brighter star, or the one that's gaining mass eventually becomes massive enough to trigger nuclear fusion and become a proper star. Either way, a fascinating ending.
Incredible stuff. Story 3, Anna, and this one involves Hubble being very, very lucky.
So this story starts with a mishap and ends up as one of the most extraordinary observational luck stories in recent astronomy.
Tell us all about it.
Okay, so researchers at Auburn University had won telescope time on the Hubble Space Telescope to study a specific comet. But then new technical constraints meant their original target wasn't viewable. So they quickly found a replacement, a different comet, designated C/2025 K1/Atlas, or just Comet K1 for short.
Routine enough so far?
Routine until one of the team, co-investigator John Nonan, sat down to look at the data the next morning, and he found not one comet in the images. He found 4, because Comet K1 was falling apart right in front of Hubble's cameras.
The comet had fragmented into at least 4 distinct pieces, each with its own coma, that fuzzy envelope of gas and dust around the cometary nucleus. And Hubble's sharp eyes could clearly resolve each fragment separately, something ground-based telescopes could barely make out as blurry blobs.
The timing was extraordinary. The comet had passed closest to the sun, its perihelion, just about a month before. That's the most intense heat and gravitational stress a comet experiences. And for long-period comets like Cone, it's when they're most vulnerable to breaking up.
And Hubble just happened to be watching. The team was able to trace the history of each fragment back in time, essentially reconstructing exactly how and when the breakup happened. This is the first time Hubble has captured a comet this early in the fragmentation process.
There's also an intriguing mystery buried in the data. There was a delay between when the comet broke up and when bright outbursts were seen from the ground. Normally, when a comet fragments and exposes fresh ice to sunlight, you'd expect it to brighten almost immediately. But this one didn't. Why? Nobody knows yet.
And the initial analysis shows that Comet K1 is unusually depleted in carbon, which gives us new clues about the primordial chemistry of our early solar system, all from a comet that wasn't even the intended target.
Best accidents in science, honestly. Onwards. Story 4 is a numbers game.
So, how many moons does Saturn have?
As of this week, 285.
285. And Jupiter?
101. The Minor Planet Center of the International Astronomical Union announced on March 16th that 4 new moons have been confirmed around Jupiter and 11 new moons around Saturn.
15 new moons just like that? I love this recurring story. It feels like somebody keeps going around the back of these planets and finding more hiding there.
Sort of exactly what's happening, actually. The Saturn moons were found by a team led by Edward Ashton from the University of British Columbia, who combed through data from the Canada-France-Hawaii telescope going back to 2019. And the Jupiter moons were spotted by a team led by Scott Shepard at the Carnegie Institution.
All of these newly confirmed moons are tiny, barely a couple of miles across, with magnitudes around 25 to 27, meaning they're far too faint to see without some of the world's most powerful telescopes.
They're what astronomers call irregular moons, captured objects orbiting far from the planet, often going the wrong way, in retrograde. Most of the new Saturnian moons are doing just that, moving in the opposite direction to the planet's rotation, which is a strong sign they were probably captured from somewhere else, either asteroids snagged by Saturn's gravity or fragments from a collision that broke up a larger moon in the distant past.
And this count is only going to keep climbing. The Vera C. Rubin Observatory went fully online last year, and it's going to be detecting these tiny, faint moons at a rate we haven't seen before.
Poor Jupiter, though, still 200 moons behind Saturn. It's like Jupiter just can't catch up.
Jupiter just needs to try harder. Okay, story 5, and this one's a little closer to home.
So here's a question. What's on the moon right now, other than dust and rock?
I mean, the flags, some rovers, a golf ball, I think.
More than 100 metric tons of human-made material. Spacecraft parts, scientific instruments, cameras, landers, crash sites. And yes, actually, bags of human waste left behind by Apollo astronauts.
We left our rubbish on the moon.
We absolutely did. And that's just what's there now. We're on the verge of a completely new era of lunar activity. Crewed missions, commercial landers, scientific rovers, resource prospectors, and nobody has a comprehensive framework for what happens to all the stuff we're about to bring up there.
There's no Lunar Environment Protection Agency. There's no international treaty specifically addressing lunar surface contamination. The Outer Space Treaty of 1967 says countries are responsible for their national activities in space, but it doesn't get into the specifics of, say, a crash lander leaking propellant near a scientifically important site.
And there are real concerns beyond aesthetics. Some of the most scientifically valuable areas of the moon, like the permanently shadowed craters near the poles, which may hold ancient ice deposits, could be contaminated by human activity before we've even finished studying them in their pristine state.
Space policy researchers and planetary scientists are increasingly pushing for binding international agreements about lunar preservation zones, impact site protections, and responsible disposal of mission hardware.
It's a conversation the space community needs to have urgently, because the missions are coming, whether the policy frameworks are ready or not. The moon has been waiting 4.5 billion years. The least we can do is think carefully before we trash it.
All right, we're ending today's show with a story that has two very different outcomes. One spacecraft recently lost, and one spacecraft recently found.
Let's start with the one that was found. ESA's Proba 3 mission, which we mentioned yesterday, has now been officially confirmed as recovered, and the details of how it happened are genuinely dramatic.
So, Proba 3 is a fascinating mission. It uses two separate spacecraft flying in precise formation at an altitude of over 60,000 kilometers to create an artificial solar eclipse. One satellite carries a disk that blocks the sun, and the other carries a coronagraph to study the faint outer atmosphere of the sun, which is normally washed out by the sun's blinding light.
On February 14th, the coronagraph spacecraft, one of the two, suffered a chain of failures that caused it to lose its orientation. Its solar panels turned away from the sun, its batteries drained, and it entered survival mode, tumbling silently through space for nearly a month.
Engineers tracked it and waited for an opportunity. That opportunity came when the tumbling spacecraft briefly turned its solar panels toward the sun, just enough to generate a small amount of power. Teams in Spain acted immediately and contact was reestablished.
ESA Director General Joseph Ashbacher said they saw that some sunlight was actually hitting the solar panels, and that was their moment. The spacecraft has now regained stable orientation and is charging its batteries. Engineers are carefully running checks before resuming science operations.
Relief all around. Now, contrast that with the story of NASA's MAVEN spacecraft, currently orbiting Mars, or at least it should be.
NASA lost contact with MAVEN on December 6th last year, after the spacecraft was expected to emerge from behind Mars after a routine pass on the far side of the planet. 2 days before contact was lost, telemetry showed everything was normal. No problems whatsoever.
But then a fragment of tracking data from the day contact was lost suggested MAVEN was rotating unexpectedly as it came out from behind Mars and was no longer in its planned orbit. NASA immediately began recovery efforts.
Those efforts have now been ongoing for over 3 months. NASA has used its Deep Space Network, the Green Bank Observatory, even the Curiosity rover, pointed skyward on the Martian surface in attempts to detect a signal. So far, nothing.
At a conference this week, NASA's planetary science director, Louise Proctor, said, and I thought this was a poignant quote, "We haven't officially said MAVEN is lost yet. We're still looking for it."
MAVEN has been orbiting Mars since 2013, 12 years of science, studying how Mars lost its atmosphere over billions of years and transformed from a potentially habitable world into the cold desert we see today. It also handles about 20% of communications between Earth and the Mars rovers.
Other orbiters, including Mars Reconnaissance Orbiter, Mars Odyssey, and ESA's Trace Gas Orbiter, are taking up the relay duties for now. And NASA is exploring options for a replacement telecommunications orbiter.
One story of recovery, one still unresolved. We'll keep you posted on both.
And that is your Astronomy Daily for Saturday, March 21st, 2026. What a show today! A moon rocket on the pad, a comet in pieces, failed stars behaving unexpectedly, 15 new moons, a moon covered in our junk, and 2 spacecraft with very different stories.
As always, links to all our source articles are in the show notes. If you enjoyed today's episode, please leave us a review wherever you get your podcasts. It genuinely helps more people find the show.
You can find us at astronomydaily.io and on social media everywhere at Astro Daily Pod. We are part of the Bytes.com podcast network. Check them out for more great shows.
Until next time, keep looking up.
Clear skies, everyone.